Welcome back. Let's talk about some hazards associated with earthquakes. So, there's two types of hazards. First are called primary hazards. Primary hazards cause damage during an earthquake, and this is directly related to the ground shaking. All right, so directly related to the ground shaking. The ground shook, so the building collapsed. The ground shook, so the bridge fell down. The ground shook, so the roadway closed. The ground shook, so the radio tower fell over. The ground shaking itself, the quaking of the earth, caused, destruction. That's what we think of. However, there are also things called primary hazards, sometimes known as the after effects, not an aftershock, but just after effects. They are associated with an earthquake, but not related to the ground shaking directly. So let's say you have a house, okay? The ground shaking, and if it destroyed your house, well, that's a primary hazard. It becomes a secondary hazard when the ground shook and that caused a landslide, and the landslide came and destroyed your house. Or the ground shook and that broke some gas lines, which caused a fire, and the fire burnt your house. Or the ground shook, which caused the ground to liquefy, and then that liquefied ground sucked in your house. Or like a picture here, a car. That's not just part of a car cut and put on the ground. That has been sucked into the ground via a process called liquefaction. Liquefaction is the liquefying of earth, turning it into quicksand. There is some land that is built on, that is developed on, that is very porous and has a lot of water content in it, especially a lot of land near shores, near edges of lakes and oceans and stuff. And if that land, if that ground, if that dirt or rock or whatever has a high water content in it, as you begin to shake it, it basically turns to liquid. Liquefaction basically turns to liquid, and anything that's on top of it kind of just falls in. Big buildings, cars in this case. So the majority of this car just got sucked into the ground because this ground liquefied during an earthquake. Another secondary hazard, tsunamis. So the earth shaking didn't destroy my house. The earthquake caused a tsunami in the ocean, and the tsunami came in onto shore and destroyed my house. What's interesting to note is that secondary hazards cause more damage than the original quake. Typically. Not always, but typically. Secondary hazards cause much more damage than just the shaking itself. Landslides, fires, liquefaction, tsunamis. Not only do these do the most damage, they typically also do the most killing as well, unfortunately. So the secondary hazards are more dangerous and deadly than just the ground shaking itself. Here are a couple videos I want you to watch that illustrate liquefaction. In fact, I'll give you a little preview just so you understand what's going on, but do watch them on your own. Let me pause this. I'll pull them up real quick. Okay, welcome back. Let's take a look at this video real quick. This is a construction crew. You can see by just walking on it, the ground is kind of moving. They're causing kind of liquefaction on their own because, this ground is, waterlogged. Now, it doesn't have to be like really thick, watery, like muddy stuff, even just a little bit of water content. Look at that. Oh, language. Look at that kind of shake like jello. But when you dig into it, it doesn't look overly like muddy. It just looks more like kind of moist dirt. It's not really muddy, but when you look at it, it kind of jiggles like jello. So that's one video. That shouldn't happen. Whatever they're building, they just probably shouldn't do that there, because if an earthquake occurred in this area, that would just act like quicksand, and whatever's there just probably just go right into the ground. Let me see. It's one more here. All right. This is from an earthquake in Japan, which you'll hear a little bit about in your assignment. But this is someone taking some video in a park in Japan. Let's see if you can hear this.
We've got a little lake, and here's a huge crack. And it's still moving.
You can see the moving earth, opening and closing.
It's just going back and forth, swaying.
Watch the water. See, kind of coming up,
kind of nervous,
going down.
especially since this is reclaimed land that I'm on right now. This used to be part of Tokyo Bay, and they created this land by throwing landfill and mountains, rocks out here. And so,
Okay, so let me see if I can back this up a little bit. Right there, you can see the water coming up. So I don't know if you heard them, but when you watch this video, please pay attention. He said that this is built on reclaimed land. So this used to be water. This used to be the ocean, but they just put a bunch of dirt and rocks and stuff to reclaim the land to create this park, which is quite common in areas near shores. So yeah, so this is just waterlogged ground, and as soon as the earthquake occurred, you can see, this whole area is kind of turning to water. Probably not a good place to be walking around. All right. In any case, check those videos out. And let's see here. So we're going to go ahead and pause right there. When we come back, we're actually going to talk about how earthquakes have helped us figure out what's inside the earth. Those layers of earth, the solid inner core, the liquid outer core, the mostly solid mantle, the solid crust. How do we know that? Earthquakes. When we come back, that's what we'll talk about. See you in a minute.